I have an exercise here that is a combination of a string exercise, maybe depending on how you do it, a vector exercise. I'm not going to do it that way though. A string exercise, a user input exercise, a structure exercise, and an exercise in using the standard exceptions. So it's a good way of combining a bunch of stuff together before we go even deeper down the exception rabbit hole. So what I have is a structure called time of day, and it contains an hour and a minute. And I've used the unsigned int type as a clever way of forcing people to keep hour and minute positive or non-negative, so 0 or positive. We don't really have any way of preventing people from using hours that are greater than 24, though, unfortunately. And as I mentioned in a previous video, that is something we're going to want to address at some point. It's on the honor system right now that people using this structure actually represent a valid time with it. And we're going to enforce that ourselves, but there's no way for the structure itself to do it. We want to operate with a view of the world where each object is a small appliance and it gets to control everything about its existence. But we're not there yet. So although I can use some typing shenanigans to prevent people from setting hour to be negative, I can't prevent people from setting hour to be 50 or something like that. I have a function called print time, which takes a time and prints it out with hour and minute with a colon between them. So I'd end up getting a representation like 1810. Or because of a simplification, if the minute is 6 or something, I might get 18:6. There is a way of making it print 06, but I figure there's a lot of other moving parts in this example. So it prints the time out with a colon between the two pieces. Then I have this big function I'm going to write in a minute, and then I've got a main function that works with this. So what I do is I create a string. Oh, oops, I guess I should remember that even if I don't have the curly brackets, it does get initialized to an empty string. I ask the user what time it is, and then I read some input, a line of input from them into this input string. I print out what they entered so they can validate it, and then I try and call my parse time function. So the parse time function above, its job is to take a string and turn that into one of these time structures. And we might already know that it sounds a lot like parse time has a similar job to the s2i function, which converts a string to an integer. It's just that parse time is doing something more complicated. Once I've parsed it, I take the time and I print it out to prove that I actually parsed it into a time structure. But there are errors that could occur. What if the user doesn't enter a time? So what if the user just enters 18 and not, 1810? What if they enter something like, this, which is not a time at all? And finally, what if they enter something that is formatted like a time, but isn't an actual time? So 1867, that is not an actual time. So our parse time function should catch all of those cases. It should handle them. Now, the way it's going to handle them, because we have to return a time structure, is it's going to throw exceptions. The parse time function has to throw exceptions because there are cases where it cannot reasonably return a time structure. Okay, so let's take a look at this, and you might want to pause the video and read the posted version of the template because it's long. So the parse time function, it takes a string, we'll call it input, and it attempts to parse the contents of that string into an hour and minute and then return one of these time of day structures. But it must throw the following exceptions in these cases. And you'll see that it says the cases must be checked in the order below. So it's possible, I suppose, that both of these cases apply. So somebody, for example, could enter as their only input the number 50. So the number 50, well, depending on how you interpret this, maybe they meant that the hour was 50. But it also means they didn't enter a valid time because they didn't enter a colon. And you'll see the two error cases. The user could enter something that is not two numbers separated by a colon. So if there's no colon, definitely we're in this case. But they could also enter something where the hour is not in the range. You could argue this falls into both cases. So the question is, what do? We can only throw one exception. And the specification says, check them in this order. Check this one first, which means if it falls into this case, throw the exception and you're done. On an exam or on an assignment, if you're told to check them in a specific order, you must do that. You will lose marks if you don't. In general, always follow the directions for the question or you won't get the marks. So if they don't enter something that is two numbers with a colon between them, then we throw domain error. So there's only so many standard exceptions. We could throw an invalid argument. The question is deliberately forcing you to use domain error because it's to try and add a certain extra wrinkle of difficulty. I will agree this is a contrivance. But anyway, domain error is one of the standard exceptions. We don't see it too often. It's often used in cases where you call a mathematical function or something that where you're providing a value that doesn't make any sense. So if you would like a real result and you ask for the logarithm of a negative number, what are you supposed to do? So domain error is used in cases like that. Although actually much of the math library doesn't use C++ exceptions at all, but that's another story. If you are able to parse it into an hour and minute, but they're not in the range that they're supposed to be, so 0 through 23 for hour and 0 through 59 for minute, then throw an instance of out of range. So this is actually a non-trivial question for so many different reasons. We're working with structures, but before we work with structures, we have to do some error checking. But before we do error checking, we have to find some way of turning a string. So suppose you gave me the string 17:10. I need some way of converting that into two numbers. So there are a few ways you could do this, and there actually are a couple of tricks in the standard library that make this very easy. One of them involves you could use the getLine function. You could also use a type called string stream, which is very clever, but I find is often overkill. I am going to do this from scratch with first principles, and you'll stare at the result and wonder what's wrong with me. The reason I'm doing that is because on an exam, you don't necessarily have Google in front of you. Now, I guess I'll hedge my bets as to whether the exams are in person or online. If you're doing a paper exam, you can't Google things. And that means you don't necessarily want to teach yourself the standard library from your notes during an exam, so it's good to be able to take a task like this and be able to solve it with nothing but basic stuff. Because whenever you bring in standard library stuff on an exam or anywhere else, you run the risk of making a mistake. If, on the other hand, you know how to work with strings and vectors really well, then it might be pretty easy to contrive a solution using those. So I'm going to do that. So what I'm going to do is this. I'm going to make two strings. I'm going to call them before and after. And they're going to correspond to the characters before the colon, so this is the before string, and after the colon. And then I'm going to sweep through my string. My input string contains a colon, if all goes well. I'm going to sweep through it from left to right. And I've mentioned in a previous video my affinity for that way of doing things. And what I'm going to do is, as I walk through from left to right, as I take each character, if I haven't seen the colon yet, I'm going to add the character to my string before. Okay, so I add the 1 to the string before. I add the 7 to the string before. When I see the colon, I'm going to switch gears. And every character after the colon, I'm going to add to the string after. And then I have two strings, each of which contains a number. And so I'll use s2i to convert them. This note here says that you don't need to worry about what the strings look like beyond the fact that s2i will either accept them or not. If s2i accepts the string, assume that it was a number. Don't worry about any further semantics than that. It turns out there is a bit of complexity there. That's why I've put this note in, for the sake of not making the exercise any longer. Okay, so my first step then is to split my input string into these strings before and after. And so I've made two strings, before colon and after colon. I'm going to loop through my input string, so I'll say for each character C in my input. I'll just do some formatting there. And then I want to ask the question, have I seen the colon yet or not? And to go through from left to right and do this, there are a few ways to do this. You could use two separate loops, one to get you to the colon, one to get you everything else. That would require indexing, which I'd rather not use. So I'm going to use a Boolean variable. I'm just going to keep track as I go from left to right. Have I seen the colon? So I found the colon. And then I'll start that off at false. When I begin the string, I have not yet seen the colon. Okay, so then at each step with each character, I'm going to ask the question, is the current character the colon? Because if so, then I'm about to switch gears. Otherwise, if I have not found the colon yet, so if, actually, I guess maybe I'll say if I have found the colon, and then a final else for the other case. So I have three cases here. Is the character that I'm looking at the colon? Well, in that case, I guess I found it. I got it dead to rights. If I found the colon already, but the current character isn't it, that means I'm looking at like the 1 or the 0. So I take the current character and I add it to the string after colon. I mentioned before, I like using plus equals when I work with strings, but you could also use push back for this. Otherwise, if the character isn't the colon and I haven't seen the colon yet, then I guess I'm still before it. So I add the character to my string before colon. I can't yet run the code without having some return value come back from this function. But as you know, when you're writing a long function, either you want to write you want to break it into smaller functions or find some way of testing it. So I'm going to do this. I'm going to return a phony value. I'm going to call this result, and I'm going to return, let's just do 6 and 10. I'm going to return some value that I know is not the actual time, but I want the function to return something so that my code compiles and I can test it. And then I can use some print statements to print out the strings that I just gathered to make sure that I'm on the right track. And as usual, the more code you write before testing, the more of a risk you're taking. And a lot of forlorn souls come to the office hours and say, Bill, my code doesn't work. What do I do? And I stare at what has to be 300 lines of code, and I say, when was the last time this compiled? And sheepishly, the answer is something like, well, never. And unfortunately, when you get too much code that doesn't work, it's often faster just to delete it. And nobody ever likes hearing that, but that often is the best advice. So we don't want that to happen. And that's one reason to test as often as you possibly can. Come up with any pretext whatsoever to test your code, and compile as often as possible to make sure that you're not making any other mistakes. So, okay, it's going to ask me for input. I'm not yet ready to work with the actual input yet beyond just parsing it, so I'll do 17 and 10. Okay, so the string before colon contains 17. The string after colon contains 10. That's a good sign. Now, if I want, these are strings still, so I have to convert these to ints to be able to use them further, but that's a good sign. Now, there is one other issue, though, which is what happens if I didn't actually enter a time? So, for example, if I type in some junk, well, then that all goes into the string before colon. The string after colon is now empty. And so I have a few things I could do here. What I could do is I could ask the question, is the string after colon empty or something? Because that's a way of testing if a colon was found. And it also takes care of a case like this where there is a colon but nothing after it. I'm going to approach it, though, in the following way. So what I'm going to do, we'll just clear this, is I'm going to deal with the exception cases in stages. The first thing is, if I never found a colon, so this is the logical not operator, so it's asking if found colon is equal to false. If I never found a colon, then I definitely don't have a valid time. And so I'm already done. I'll just throw an exception now. It says in the description that I'm supposed to throw domain error if that happens. So if the string is not two numerical fields with a colon between them, then I throw a domain error. So I'll throw domain error. If there was no colon, there's definitely not two numbers separated by a colon. So let's see, invalid time. I can't think of any. I mean, I could say there's no colon in it, but I don't know if that's too helpful to whoever's using this code. So I can, in this case, I think a less descriptive message isn't that big of a deal. Okay, so if there's no colon at all, then clearly there's no time. It's not a valid time. The next thing is I have to check whether they are two numerical fields. So I'm not worried yet about whether they're in the range, but I want to check whether I have two numerical fields. I think what I'm going to do now then is parse them into ints. I'm going to say, well, int hour. I'm not yet ready to use my time of day structure for a reason that'll become clear in a minute. Int hour equals, well, I'll call s to I. I'll try converting my string before colon to an integer, the integer hour. And then minute equals also s to I. Now I know that in the event the user entered something that wasn't a valid number, s2i will complain. We know already, of course, that s2i will throw an exception if it's unable to parse the number. So I'll put this whole thing in a try block. I will ask the question, did s2i successfully parse the number? If the answer was no, if it threw an exception, then I will be done. So I'll say I want to catch a invalid argument exception. So recall that s2i throws invalid argument if it's unable to parse. And if that happens, as I mentioned above, the specification is insistent that I throw a domain error. So I do this. I just stick a throw statement inside my catch block. The previous video talked about this. So it is valid to do this. We often find ourselves doing this because we have to switch up which exception we're working with. We catch one kind of exception and then throw a different kind. Okay, so I didn't catch myself. You might have seen I wrote C-style initializations here, which is a no-no. But it turns out I'm about to change the code anyway because I realized on line 62, if an exception wasn't caught, if s2i succeeded, then I'm going to want to work with my variables hour and minute. So what do I do? Well, I can't work with them on line 62 right now because the two variables hour and minute are scoped inside of this try block. So my options are either to put the rest of my function inside the try block, which is valid. It's a completely valid way of doing business, but a little bit sort of ugly. Or I could observe that if I get down to line 63, there wasn't a problem. And therefore, I could just declare my variables outside the try block and set them inside the try block. So I could do something like this. And we saw before that, of course, if an exception gets thrown, these assignments don't happen, or whatever assignment we're on fails, but then I'm going to throw an exception. If I get down to line 63, therefore, it's reasonable to assume that the try block completed with no exceptions, because if an exception occurred, it would have been thrown, or something would have been thrown right afterwards. If anything got caught, another exception would have been thrown immediately afterwards. That means if I get down here at this point, are valid, and well, were parsed successfully from the input string. Okay, so at this point, I've managed to resolve this first error condition. So making sure the string contains two numbers separated by a colon. I checked for a colon specifically, and then I tried to turn the thing on either side into a number. Now what I have to do is verify that I have a valid time. It says if the hour is not in the range 0 through 23, or the minute is not in the range 0 through 59, throw an out of range exception. So I could, for example, enter a negative hour or a negative minute, or I could enter 25 as the hour. That is why I deliberately used int as the type for hour and minute. Even though in my time of day structure it uses an unsigned int, I am deliberately using int so that I can check that hour and minute are both non-negative. Because, of course, unsigned int will never have a negative number in it, so we'll have no way to tell. So now I ask the question if hour is less than 0, or if hour is greater than 23, or, and you could split this up depending on the application. There are cases where you want to throw separate exceptions, but in this case, I'm going to stick with the message invalid time. I think a very sensible way to write a piece of code like this is to begin by throwing vague exceptions until you get everything working. And then as you test, decide whether you want to build in more descriptive messages. If minute's less than 0 or minute is greater than 59. Okay, so if any of these cases occur, then I'm in trouble, and then I have to throw an out of range exception. So I throw std out of range, and I just say invalid time. If I chose to do so later, I could split this into 2 if statements or 4 if statements that throw specialized exceptions, one of which being like invalid hour, invalid minute, or hour can't be negative, or minute can't be negative. But here I'll just say, hey, if the time is invalid, the time is invalid. So I throw out of range. And then when I get down to line 67, I didn't throw any exceptions. That means I think everything is good. So I could create, here I'll create my time of day object, my result, and I could then set the hour and minute. I could write result.hour equals hour, result.minute equals minute. That's not the only way to do it, but I'll show the other way after I try it out. Okay, so what time is it? It is 6:10. And it prints out the time is 6:10. So it prints out what I entered as a string, but it prints out the time as a time of day object, which means it is actually parsing it successfully. Okay, we'll try 17:10. Okay, so that looks good. But what about if I enter something invalid? So 187. Well, here the minute is invalid, and I see it throws out of range. If I enter something that isn't a time at all, I get a domain error. But again, that's my function producing that. So my function is in control here. And then finally, what happens if I try this? Well, in this case, if I type an hour but no corresponding minute, I also get a domain error because it still is not a valid time. Notice how I do not get an out of range exception. Because of the rules in the specification, which said that when an error falls into both categories, handle this one first. That means that this is not a valid time for 2 different reasons, but the exception I get is domain error because it doesn't contain a numerically valid hour and minute. It's true, this is also out of range, but I throw the domain error in this case. Okay, a couple of other points. So I could initialize my result structure rather than using assignment statements. I could just do this. I could use a curly bracket initializer just to set each field. So we'll verify that that isn't too, I mean, I don't think we should be too surprised. And it's a matter of personal taste, which one that you do. You'll notice if you do it, you do get this warning that, wait a minute, this is an int, not an unsigned int. So I suppose I could shut it up by writing this. Like, whoops, I could say, I get it, it's an unsigned int. So explicitly force the value into an unsigned int because I've already checked that hour is not going to be negative. But if you do the curly bracket initializer, you get initialization rules applying. And you know from what we talked about with uniform initialization, that when you use uniform initialization, it does warn you if you try to assign one type to another, even if the conversion is otherwise allowed. Okay, so we'll try this again, and we can see the time is still 6:10. Okay, so one thing left to do, which is I have to handle the error cases that could arise. So here, I want to be able to handle when the user does not enter a valid time. I don't just want to see the cryptic, well, I'll run it to show that off. I don't just want this cryptic operating system or runtime system message saying, sorry, the program died. I would prefer instead that my program remain in control. So what I'll do is I will try this, and I have to put this whole thing in a try block because the variable t is initialized to this value. So if an exception gets thrown in this constructor, during the initialization, while preparing the initial value, then t isn't going to exist, which means that if I want to print t, I have to be in the same scope as t. Okay, so I'm going to catch, well, the two things I could catch are domain error and runtime error. So I catch the domain error, and that's a case where it wasn't a valid time. And then I could also catch I guess it's domain error and out of range. And this allows me the opportunity in main to print customized error messages specific to the problem. So you did not enter a valid time. I suppose the domain error is general enough, it's hard to tell exactly what was wrong with the time. And then down here, out of range, hour or minute is out of range. And so we'll try that out. Okay, so we'll try 610. That looks good. We'll try 1810 to make sure we remember how to use a 24-hour clock. That looks good. I'll enter some junk. It says you did not enter a valid time. The program remains in control. I enter 50 : and again, that's the domain error case, so it says you did not enter a valid time. But what if I enter something like 2563? We can see here the hour or minute, in this case actually it's both of them, is out of range. And so I think that's a good way of tying together a whole bunch of material we've already covered. It's a pretty verbose solution when you look at it, because it of course hits a bunch of different bases. It's not just about strings, it's also about structures. And it's not just about strings and structures, it's also about things like exceptions. The key thing, if given an exercise, even one of this difficulty on an exam, is try and work through it in stages, break it down into first turn the string into numbers, then deal with whether the numbers are valid or not, and then worry about the structures. If you can find a way of turning it into sort of an assembly line solution, here's the string stuff, here's the exception stuff, and then here's the structure stuff, it's often not only way easier to get the right answer, but also easy, even if the answer is wrong, to get partial marks, because it's easier to see which parts of the question you were able to achieve.